In this part of Unit 8, we're going to learn about logarithmic functions and what logarithmic functions are. So a log is with a base of b, so that's going to be this little number here, that's our base. It's a base of b if you have a positive number x that satisfies the following definition. So it's read, log base b of x equals y if and only if x equals b to the y power. So what I'm saying is that you can change this log function into this exponential function. They are related to each other. So we talked about exponential functions in the first 2 days of this chapter, but now you can take that log function and change it into the exponential function. And that's what our first example is looking at. We're looking at rewriting log functions and exponential functions into the opposite form. So this first example, we have 4 equals the log base 3 of 81. Notice how I read that. Log base 3 of 81. It's important to know how to read that so that you're reading it correctly. So when you rewrite that, you take the base and it becomes the base of the exponent or of the exponential. Then 4 is your exponent, so 3 to the 4th, and then equals 81. 3 to the 4th equals 81. So that's rewriting the log function into an exponential function. And we can do the opposite. We can write an exponential function as a log function. So here we have the exponential function 36 equals 6 squared. We all know that's true. 6 squared equals 36. It's something you learned back in elementary school. But we can rewrite this as a log. So it would be log base 6 of 36 equals 2. Now, the 6 comes from the base here, the 2 is over here, and the 36 goes right there. So log base 6 of 36 equals 2. That's the same as saying 6 squared equals 36. So a little bit more about logs. The common log is a logarithm with a base of 10. So you may see it like this with a base of 10, but most often you'll see it without a base. So if you just see log of x, that means the base is 10. If there is no base indicated, then the base is 10. And how the logarithmic function and the exponential function are related, they're inverses of each other. So if you look at this picture, you have the exponential function and the log function. Notice they are inverses of each other. 110 is the inverse of 10-1. And you have those two, the inverse of the two. So the logarithmic function is the inverse. So when we were going between those two forms and rewriting it earlier, that's just finding the inverse of the function. In graphing logarithmic functions, the shifts are going to work the same as we've been learning throughout the whole year. That h is going to shift it the opposite of it, so it's going to shift it left or right. So if it's negative h, it's going to be positive h, so you'd be shifting it to the right. Then k shifts it up or down. If it's 2, you shift it up 2. If it's negative 2, you shift it down 2. Now, logarithmic functions, they don't have any other things special, any tricks to learn about how to graph them more easily. So what you're going to be doing, you will be learning you learned how to do this on your app, that Desmos app, and you're going to be graphing all of your logarithmic functions through that. So hopefully you learned in the investigation how to type that into your graph, into your grapher app, and you'll be able to use that to graph any of the logarithmic functions that you have. Next, we're going to learn about some properties of logarithms. The product property, the quotient property, and the power property. So the product property if you notice, we have m times n here. That's multiplying. So anytime we have m times n, we can expand that and turn it into an addition problem. So when you're multiplying two numbers together after the log, you can expand and turn it into an addition problem. So the log base b of m times n equals the log base b of m plus the log base b of n. Then the same thing works for the quotient property. If I have two numbers that are divided, so m divided by n, the log base b of m divided by n turns into a subtraction problem. So it'll be the log base b of m minus the log base b of n. We'll be seeing these shortly in examples so that it'll make better sense to you. Then the power property, if you have some number to the power, that power can just come out front. So log base b of m to the n power becomes n times log base b of m. So here's how we're going to use those properties. We're going to start off simple today, and then we'll make it a little bit more complicated tomorrow in your tomorrow's notes. So if we want to expand, if you think about expanding, that means whatever you have is going to get bigger. So if I'm expanding this expression, it's going to be longer than what it originally started as. So here, I just really want to focus on this piece here that I'm going to put in a box. So it's x to the fourth. Now I said if I have a power, that power can come out front when I expand it. So this becomes 4 times log base 3 of x. All I did was move that power out front. And that is my final answer. Okay, so remember, today we're just starting off with simple ones. So this is 4 log base 3 of x. In the next example, if I just look at that piece that's after the log, 4 times x, we learned that if you have multiplication, it changes into addition. So you have log base 3 of 4 plus log base 3 of x. And now you've expanded it as far as you possibly can. I don't have any powers, I don't have any multiplication, I don't have any division. So then when you don't have any of that, you know you've expanded it as far as you possibly can, and you have your final answer. In the last example, if I look at that piece after the log, I have division. So with division, we change it to subtraction. So log base 3 of 4 minus log base 3 of x. Okay. So if it's division, it changes to subtraction. If it's multiplication, it changes to addition. And if it's a power, it moves out front as a coefficient. And the reverse is going to work also. So the next examples we're going to look at doing the reverse of this. So in these examples, we're condensing the expression. We're going to make them shorter or smaller. When something gets condensed, it's going to shrink. So you always want to look at, if it's long like this, you want to look at that middle math expression. So here it's subtraction. So subtraction then turns into division. It's the opposite. So here we'll have log of 7 divided by 3. 7 and 3. And you can just leave it just like that. And notice there's no base here, so it's a common log, which means the base is 10. In the next one, we have addition. Addition changes into multiplication. So we have the log of 7 times 3. Now, because it's 7 times 3, we should multiply those together and get the log of 21. So the log of 21 equals the log of 7 plus the log of 3. Those equal each other. In the last one, because I have this x out front, that x is going to be my exponent. So this changes into log of 7 to the x power. So these 6 examples with these properties were pretty basic examples. On your notes tomorrow, we'll do some that are a little bit more complicated to get you guys more used to using the properties.